Hey everybody, I hope you're doing well. It's Mr. Belk. We're going to talk some more about infinite series today. We're going to talk about convergent infinite series. So what that means is you'll add them up forever and ever and ever, and it will converge, or it will get technically really close to a number, and then so close that we just kind of consider it to be that number. Okay? And what you can actually do is there's a formula where you can actually find that number. And then here it is. So it's actually, surprisingly really simple. You might think, oh man, this is going to be terrible. No, it's actually very simple. And it's just S infinity. So that just means the sum of all of these numbers added up forever and ever, is A1, so is the first term. And then you divide by 1 minus R. So the two things you need to do while you're doing this is you need to find R, and then you need to plug it into the formula. And I guess you also need to find the first term. And I think you guys are certainly capable of doing that. So let's look at a couple examples. They can give you the list of the numbers added up together like this, or they can give you the sigma notation, which we will talk about how to do that on your calculator. So first of all, let's start with this one. So first thing we got to do is we got to figure out what A1 is. So A1 is the first term right there. A1 is 1, which it won't always be 1, but in this case it is. And then R, okay. So R you can find by doing the second term divided by the first term. And when you do 2 over 3 divided by 1, you will just get 2 over 3. Okay, so now let's go on to plug it into the formula. So S infinity, I've got 1 for my first term, and then I'm going to divide by 1 minus 2 over 3. So make sure you plug this in your calculator carefully. Do 1. Oh, I see I haven't plugged it in right. You want to do 1 and then divide by, in parentheses, you're going to do 1 minus 2 over 3. And you make sure you put that denominator in parentheses so it will divide properly for you. And doing that, let's go see what it spits out at me. 3. So this tells me that this sum is 3. If you were to add those up forever and ever and ever, you should get 3. Okay, let's keep going. Let's talk about one that's a little bit harder. Maybe that one seemed too easy. So for this one right here, again, you just want to talk about what your first term is. So my first term is 7. And then figure out what R is. So R is 21 over 4 over 7. More fractions. So I'm going to do 21 over 4. I'm going to divide it by 7. Figure out what R is. So 21 over 4. I haven't put parentheses around that, so I'm going to do that and then divide it by 7. And that gives me 0.75. And you can use that decimal, or you can change it to a fraction, and either way is totally fine. So this R is 3 over 4. And for all of these examples, you don't need to figure out whether they're convergent or divergent. All of these examples will, and what you're doing today will converge. You just have to use the formula. So this tells me S infinity. I'm going to take my first term, 7, and then divide by 1 minus the R, which is 3 over 4. So I'm going to do 7, divide by, and then in parentheses, I'm going to put 1 minus 3 over 4. And make sure you put that whole thing in parentheses. So this series will converge to 28 once you get done adding up the infinite number of things in there. Okay? Let's go talk about a couple more. We got one more with some negative numbers here. And then we can also talk about sigma notation. So this one, our first term is negative 10. And then if you go look at, or if we try to go find R, let's go find what R is. R is this term. Make sure you bring the negatives with it. So negative 15 over 2, divide by negative 10. And I'm going to use my calculator for that, because I will surely make a mistake doing that by hand. So I'm going to do negative 15 over 2, divide what I just got there by negative 10. And doing that, I'll get 0.75 again. Now, it's a popular number, which is 3 over 4, like we just did. So now in my formula, I want to find this infinite sum. I've just got to do negative 10 on top, and 1 minus 3 over 4 on the bottom. And since it was two negatives, you may think R comes out to be a negative number there. Since all the terms in your sequence, or this is a series, are negative, that means R is actually positive because the signs are not changing. If the signs are changing, that's when R will be negative, and doing this dividing process will make it come out to be negative. Okay, but again, let's go plug this in. So let's do negative 10 and divide by. I'm still not dividing. Got to divide by 1 minus 3 over 4 and see what that comes out to be. Negative 40 in this case. All right, so let's highlight that. So that's what this series is going to converge to, negative 40. And let's go talk about the last one and talk a little bit about sigma notation in your calculator. So even though this is an infinite series, what we're going to do is we're going to use our calculator to estimate this, because our calculator, you can't actually put infinity on there. Let me go to math, and if you scroll all the way down to the bottom, there's a summation option, which you should have been using from the other days. And let me plug in x equals 0. And see, when you get to the top of plugging this in your calculator, there's not a place for you to, there's not something you can put infinity in, but what we're going to do is that eventually these numbers will get so small that the adding the next number will not increase the series. It won't make it any bigger. So what we're going to do is estimate this at 99. So adding up about 100 terms should actually be enough for us to get the correct number out of it. And your calculator may sit and think for a minute while it does this, because it may be stretching its brain out a little bit, but that's okay because it's adding up 100 numbers. While you're doing this, make sure you're careful to use the parentheses. So this, the parentheses on the calculator, we're going to treat as an extra set right there, kind of plug it in like that. So raise this to the x power. And like I said, it may think for a second and spit out your sum. So you don't need to change this and use the formula when you have the sigma notation. Your calculator will do it for you. And see, it didn't come out to anything crazy. It came out to just 9, which is the right answer. Okay, so you can actually use 99, and then the 100th term, I guess what I'm trying to say is that the 100th term is so small that it's okay to use 99. When you're plugging it in your calculator though. And then when you do that, you'll get 9 out, and that's your answer. I hope this helps you guys.